Hello everybody and welcome to another exciting video for the enVision's math book for Algebra 2, Topic 3, Lesson 5, Example 3. And in this one we're still going to be investigating and looking at how these roots or zeros or the x-intercepts help us find the difference between complex zeros and real zeros. So looking at the graph, we have this nice odd graph, and we do have an odd degree here in x cubed. It is a positive leading coefficient, so the right arrow should be going and pointing towards positive infinity. And we have 1, 0, even though we have a degree of 3, which means that we can have up to 3 real solutions. We only have one real solution. We have the one real solution, that x equals 2. So let me grab this guy right here, and let's use this to determine, I have the function there, but I decided I want the whole graph. Let's use this to determine our real solutions and then our complex solutions. And remember, complex solutions will look like something like, I don't know why I put the parentheses, a plus bi, where I is the imaginary value. All right, so what I'm going to do is I'm going to take my real solution, because my real solution is going to become a factor of my polynomial. And in this case, it's x equals 2. And what I'm going to do with this is I'm going to use synthetic division. And I'm going to factor out the x minus 2 factor, or when x is equal to 2. Take my coefficients here. So this is 1, 1, -3, -6. My sound effects there. And for synthetic, I'm going to take this first value, pull it down, and then start my multiplication, start my pattern of multiplication and addition. So 1 times 2, 1 times 2 is 2. Then I'm going to add going down. 1 plus 2 is 3. 3 times 2 is 6. Add going down. -3 plus 6 is going to be 3. 3 times 2 is 6. Add going down is 0. If we did not end up with a 0 here, we did something really wrong. So when we have a remainder of 0, that means that x minus 2 is a factor. And I keep mentioning x minus 2. Well, where did this x minus 2 come from? Well, remember I said that we have x is equal to 2 as our solution. I'm going to reverse that zero product property. I'm going to get this equal to 0. So I'm going to subtract 2 from each side. And my factor now, or one of my factors, and I'm going to have 3 because I have a degree of 3, one of my factors is going to be x minus 2. All right, so now I'm going to rewrite this into the quotient of x times the divisor of x, and my divisor in this case is x minus 2, plus my remainder of x, and my remainder is 0, so I don't have to worry about that. All right, so q of x, this is 1x squared. So I'm going to do 3 times 1, which is 3. 3 times x, which is 3x. And 1 times x squared, which is just going to be x squared. And then x minus 2. Okay, so this one right here, this x squared plus 3x, I'm going to focus on that. So I'm going to kind of pull this out into a thought process, into a thought. This guy's going to fall down, and it's going to follow along, but it's not really being focused on right now. All right, so we have x squared plus 3x plus 3. And I want to think of 3 numbers. So I have, 2 numbers that multiply to give me 3. And I have 1 times 3. And looking at this, if I add them, I cannot get 3. There's probably no way that I could have 2 factors equal to 3 and add to get me 3. I mean, I could sit here for a very long time just trying to think of how I can manipulate that. But since it's not easily manipulated and I'm trying to look for the solutions, what I'm going to do here is I'm going to use the quadratic formula. All right, so A is equal to 1, B is equal to 3, and C is equal to 3. So the quadratic formula is negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2A. Okay, substituting the values in, I get x equals negative 3 plus or minus the square root of 3 squared, and I'm just going to throw that in there. 3 squared is going to be 9, minus 4 times 3 times 1, so minus 12. All divided by 2 times a, which is going to be 2 times 1, which is 2. All right. So again, I still have x equals negative 3 plus or minus 9 minus 12 is going to give us a negative 3 divided by 2. Again, remember that this solution of x equals 2 is following us down. So we also have that solution of x equals 2 over here. And looking at this, simplifying it a little bit more, putting in the a plus bi. I don't want red, I want the black marker. I have negative 3 divided by 2 plus or minus. Remember, the square root of negative 3 actually comprises of the square root of negative 1 and the factor of the square root of 3. So two factors multiplied together to get us the negative 3. I know from previous lessons that negative 1 is that imaginary. The square root of negative 1 is that imaginary. So I'm going to pull out that imaginary. Root 3 divided by 2. All right, with this plus or minus, that means we have two different solutions. We have x equals negative 3 halves plus the imaginary 3 divided by 2, negative 3 halves minus I3 divided by 2. And my last solution was that 2, where we cross the x-axis. So these are three solutions. And again, notice how we have a degree of 3 here. And we ended up with 3 solutions. All right, so let me put this right here for a moment so you guys can see that. And then we're going to go look at which your try is. Or we'll look at what the buck does. All right, so let's look here. So they do find the 0, being that 2 will equal 0. We did it through synthetic division and saw that my remainder is 0. And per the factor theorem, if the remainder is 0, then that value is a factor. So my factor is x minus 2 times x squared plus 3x plus 3. Then they use the quadratic formula as well. I should have put the I on the outside. That looks a lot cleaner. And they got the 2 solutions. All right, so the first try, again, you're going to use this graph, the information that you know, the fact that x equals 3 here, and the synthetic division to pull that out of this first set. To figure out the other 2 solutions, the other 2 complex solutions. Now here you have 2 x equals. What is that going to do? Do we have to do synthetic twice and pull out those factors, the factors of x minus 2 and the factor of x plus 2? Which one do you choose first? Does it matter which one you choose first when you do the 2 synthetic divisions to pull those out? So this is things that you should think about when you're going through this. Let's go back, look for the relations. The function's graph crosses the x-axis at 2. The y-x-intercept of the graph is 2, so f of 2 should equal 0. 2 is the 0 of the function, which means x minus 2, notice the sign change here, is a factor of the polynomial. All right, so there you have it. There is example 3, very long, complex. But again, if you have questions, please get a hold of me, and I will see you in the next video.